All right, we're going to come through and I'm going to go over how to do a load calculation for a residential service. If we come up here and we look, I sent this out to you in an email that gives you the square footage of the dwelling in question, a list of the appliances, and we're going to go through using the National Electric Code, and I'm going to go over how to figure your load calculation. So if you'll print this off of your email or refer to it on your email so you'll be able to do it, and what we will do is I'm going to go over how to do the load calculation for your Mod 11 performance profile. First thing we've got to start off with figuring out is our general lighting load for the occupancy. If we look right here, I've put in here that you've got to refer to table 220.12 in the NEC. So if we come over here and we scroll down to table 220.12, and we look up here and we find dwelling units. Dwelling unit says that I have to have 3 volt amps per square foot. Come back over here. I've got a total of 3,200 square feet. So you're going to put 3,200 square feet in here times 3 volt amps, and it will give you your total volt amps for this dwelling unit for the general lighting load. As we move on, we're going to come back in here and we're going to look at 2 other sections of the code. Our small appliance circuit. Our small appliance circuit, the first place we're going to go look is 210.11C1. If I come up here and I go to 210 and we come down to 210.11, we come up here 210.11, C1, it says in a dwelling unit for small appliance branch circuits, in addition to the number of branch circuits required for other parts of this section, 2 or more 20 amp small appliance branch circuits shall be provided for all receptacle outlets specified by 210.52 Bravo, which is explaining what we have to have in the kitchen. Another thing I want you to look at is 210, or is the laundry branch circuit here. In addition to the number of branch circuits required by other parts of this section, at least 1 additional 20 amp branch circuit shall be provided to supply laundry receptacle outlets, and it takes us to 210.52F. One thing I want you to take note of here is that number 3, although we are not doing that on this formula or on this particular exercise, bathroom circuits. In addition to the number of branch circuits required in other parts of this section, at least 1 120 volt, 20 amp circuit shall be provided to supply bathroom receptacle outlets. Now, we're not asking for the bathroom outlets here, but what we're going to do is we're going to come up and under the small appliance, I'm going to have 2 at 1,500 volt amps, which is going to bring me over here, 2 times 1,500, you'll fill that in. I'll have 1 laundry circuit, 1 at 1,500. In my general lighting, I'm going to come up here, and where we got this number, we're going to put that under general lighting. We'll add all 3 of these together, get a subtotal. Now, we'll bring our subtotal down here. We're going to come back to the code, and we're going to look at what it says in table 220.42. So if I come over to the National Electric Code, and I go back to 220, and we come down and we look for the table in 220.42, that's going to bring us right here. And we're going to go to dwelling units. For our first 3,000 volt amps, we're going to take 100%. From 3,001 volt amps to 120,000 volt amps, we're going to take 35% of that load. If we go more than 120,000, we'll take 25% of anything over 120,000. So let's come back and look at our sheet. We got our general lighting load, which we got right here. I've got my small appliance, and I've got my laundry. And we're going to figure our subtotals. So we add them all together, we come down here. My first 3,000 is going to be at 100%. You're going to bring 3,000 over here. I'm going to subtract 3,000 from this number. As long as it's not more than 120,000 volt amps, that's going to go here. We'll take 35%, or multiply it times 0.35, and we will place that number right here. You're going to add the 3,000 plus this number, and you're going to bring it down here to the total general lighting load. Now, let's go back, and we're going to look at 220.55 and 220.54, where we're dealing with our range circuit and our dryer circuit. Let's come back over to our National Electric Code. If I come down here and we go to 220.55, which is this table right here, the range they gave us said 12,000 volt amps. Well, if I come up here and I've got one range and it's not over 12,000 volt amps, I'm going to take 8,000 volt amps, or 8 kilowatts. Now let's go back and we're going to look at what it says about our dryer. On our dryer, electric clothes dryers. The load for household electric clothes dryers and dwelling units shall either be 5,000 watts or volt amps, or the nameplate rating, whichever is larger. Well, our nameplate rating on our sheet said that we were going to use 6,000. Now I come to my table and it says with 1 to 4 dryers, I'm going to take 100%. So let's come back over to our sheet. For our range on our table 250 or 220.55, we're going to take what it said there in column C, which is going to be 8,000. For my dryer, I had more than 5,000, so we're going to go to 6,000. That's what my nameplate rating is. So that takes care of our range and our dryer. Now let's look at other fixed appliances. Our other fixed appliances on here, it'll just come up here and transfer these right from where it gave our specifications at the top. We'll transfer these numbers to those fixed appliances right here into this spot. Then we're going to go to Article 220.53. Let's see what Article 220.53 says about our fixed appliances. If I come down here, 220.53, appliance loads, it shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances fastened in place other than electrical ranges, clothes dryers, space heating, and air conditioning equipment. So everything that's not your cooking equipment, your clothes dryer, and HVAC equipment is appliance load. Now, do we have more than 4? Let's come back here and look. 1, 2, 3, 4, 5, 6. So I've got more than 4. We'll add all these numbers up. It'll come over here in the subtotal. According to this part of the code, I'm going to multiply that times 75%, or 0.75. and that will give me my small appliance total. Now, if we come down here and we look at 430 in the code, I'm going to bring it up. 430 in the code says when I'm figuring a service with a motor, I take my largest motor and I'm going to multiply it times 125%. But I'll show it to you in the code. Come up here, what I'm looking for in the code is 430.24. So I'll come over here. To 430.24 in the code book, 125% the full load current rating of the highest rated motor. So we're going to come back here. Now I've already got 100% of my attic fan right here. So I just need another 25%. So I'll take my attic fan, I'll recopy it down here at 1600 volt amps times 25%, which will give me 400 volt amps. Electric furnace. I don't have the rating here, but let's see what it says. An electric furnace is a fixed in place heating. So I'm going to come back to 220. And we're going to see what it says about fixed in place heating. So I come back over here. Electric cooking. Small appliance. Fixed electric space heating. So I'm going to take 100% of my fixed electric space heating. So my space heating, my furnace, is 3,000 or 30,000 volt amps. Now the reason I don't have my air conditioner here, let's come back over here and look what it says about non-coincidental loads. Non-coincidental loads. For it is unlikely that two or more non-coincidental loads will be in simultaneous use. It shall be permissible to use only the largest load that will be used at one time for calculating the total load of the feeder service. So if we come back here, we're not going to run the heat and the air conditioner at the same time. Therefore, we're only going to use the furnace. So I'm going to put my furnace times 100%. That'll go here. We're going to go back up. We're going to grab our range. After we look at the table, it'll go here. We're going to grab our dryer. That'll go here. We're going to come down here and we're going to grab, after we've done the 75%, we're going to grab our fixed appliance loads. It'll go here. We're going to add the 400 right here for the largest motor. Then we're going to go back up here where we transferred our total general lighting. It's going to go here. We'll add it all up together. Once you have all that added together, it gives you the total volt amps for your service or your total calculated load. You're going to take your total service load, put it here, divide it by 240, and it'll tell you how many amps your service has to be. Now that we know how many amps our service has to be, we're going to come down here to table 310, 15 Bravo 16. Let's come back over here to our code. 310. We want to go to our table that's got our ampacities for various wires, which is 15 Bravo 16. So I'm going to bring this up. Now, once we figure out our ampacity, we look over here. It's telling me that it wants to know what size wire I need for THW copper, or what size wire that we need for THW aluminum. So we'll come back here. On the copper side, you've got a copper side, you've got an aluminum side. You're going to come up here to THW. You're going to come down here and find out what your amperage was. and then you're going to come pick whatever wire size that it says for your correct amperage for THW copper. Then you're going to come over here and you're going to find the THW under aluminum. You're going to come down and find your amperage and come across and find out what size wire net size you need for your aluminum. Once you have found that, you will come back over here and fill it in, whether it's American wire gauge or K circular mills, KCML. Once you've got that, then we're going to come over and we're going to figure our neutral load. For our neutral, we're going to take all of our 120 volts, come back. I got a dog trying to help me teach. We're going to come back. We're going to take the general lighting load. We're going to take our general lighting load that we had right here. We're going to bring it over here. We're going to take our fixed appliances. So we come up here, grab our fixed appliance load that we had right here, and it's going to go under fixed appliances. We're going to take the one for the largest motor, and it's going to go under largest motor. We're going to come back and look at range load and dryer load. It tells us to go to 220.61b. Let's see what 220.61b says in the National Electric Code. We're going to come back to 220. We're going to go to 61 Bravo. 1, 2, 4. 220.61b tells me the feeder or service neutral load shall be the maximum unbalanced load determined by this article. The maximum unbalanced load shall be the maximum net calculated load between the neutral conductor and any one grounded or any one ungrounded conductor. I'm going to come back over here and we're going to look at B. We come up to B, if you'll remember, we used our tables, and it said service feeders supplying the following load shall be permitted to have an additional demand factor of 70% applied to the amount in 220.61b1 or b2. And if we look, and I come up here, it talks about household electric ranges or dryers if we use the table. So we're going to come back down here. We had 8,000 volt amps for the dry range. We had 6,000 volt amps for the dryer, but we can take another 70% or times 0.70 on each one of these, and we'll bring that number over. We will add all of this up in this column, and that will give me my total demand. That's on my neutral wire. On my grounded conductor, I'm going to bring my total demand over, and I'm going to divide it by 240 volts, and that will give me amps. That is how many amps my neutral conductor has to be capable of carrying. So now I want to find out what size neutral conductor I have. We've got our amps. Once again, we're going to go to 310.15 Bravo 16, our chart. Come back over here for my ampacity chart. I'm going to go to 310.15 Bravo 16. And they're telling us we're looking for THW again. I'll come down here. When I find what size amperage I got, when I did that math, I'll move back over to the first column, and this column here will tell me what size wire I need for my neutral wire based on my load ampacity for the neutral. And then I'll come over here in the copper column, the aluminum column, and I'll do the same thing. When I find and I've got to be bigger than what my answer is, the same size or larger. And then I'll come over, and that'll tell me what size neutral wire I have to have if I'm using aluminum. Now that we've done that, finding my grounding electrode conductor is going to be easy. I'm going to come back to whatever size we had here. And then we're going to come down here and look at table 250-66. So if I come back to the code, we come up to Article 250, and I'm going to be looking for 250-66, which is going to give me a table for sizing my grounding electrode conductor. Let's see where I am. $250.32. Keep going until we get to 250.66. 62, 64. My next page. Somewhere in here, I should have my table. Back up one page. I'm looking for my table. And of course, now I can't find my table. Table 250-66. There's my table. I come up here, table 250-66, grounding electrode conductor. You remember what I said? We're going to come back up here. We're going to find out what size wire we needed for our service entrance cable. We're going to come down here looking for the grounding electrode conductor. Whatever size wire that you needed for copper over here, you'll come over here and it'll tell you copper. Whatever size I need for aluminum, you come over here and it'll tell you what you need for aluminum. That's all there is to doing your service entrance and figuring out your wire size for the service on a residential service. Thanks a lot. I hope you enjoyed it. Have a good day.